We'll continue with the previous derivation. So we are having the values of A and B, which we have already derived. So A is f0 k minus m omega square divided by k minus m omega square bracket square plus c omega square. Now we have assumed k minus m omega square is equal to z cos phi, then c omega is equal to z sin phi. Then we have derived z is equal to k square root of 1 minus r square bracket square plus 2 zeta r bracket square. And then x is equal to a sine omega t plus b sine omega t. Value of b also we have derived, and this is the value of b which we have written over here. Now we have to simplify or modify these values of a and b. Now, in place of k minus m omega square, we can substitute z cos phi. Similarly, in the denominator also, in place of k minus m omega square, we can substitute z cos phi, and square of the bracket is there. Plus c omega is z sin phi and bracket square. So we'll simplify now mathematically this particular expression. So a is equal to f0 z cos phi as it is. In the denominator, we will have z square cos square phi plus z square sin square phi. So numerator will keep it as it is. From the denominator, we can take z square common. So it is z square inside the bracket cos square plus sin square, and cos square plus sin square is 1. 1 z will also get cancelled out. So value of a that we can obtain is f0 upon z cos phi, and similarly we have to find out the value of b also. So b is minus f0 c omega divided by k minus m omega square square plus c omega bracket square. Now substitute the value of c omega. C omega is nothing but what? It is z sin psi divided by k minus m omega square is z cos phi and square of that. C omega again it is z sin phi and square of that. Simplify in the same fashion as we have done earlier. So this is nothing but z square inside the bracket cos square plus sin square, that is nothing but 1. Cancel out 1 z from the numerator as well as from the denominator. So we can say that it is nothing but, and this cos square plus sin square is 1. So it is minus f0 by z sin phi. So these are the values of a and b which we can easily substitute in the expression of displacement x, that is a sin omega t plus b cos omega t. So this was our first expression. Now value of a is f0 by z cos phi sin omega t, and b is nothing but minus f0 by z sin phi, and is cos omega t as it is. f0 by z you can take common, so it is cos phi sin omega t minus sin phi cos omega t. So we can represent x in terms of, now this is the formula of sin alpha minus beta, sin alpha cos beta minus cos alpha sin beta. So this first term is representing the amplitude which is dependent on this external force and its rate, and the second part is the frequency or direction of the motion. So in this way we have represented x in terms of f0 z. Then this is the form of the expression of simple harmonic motion, so amplitude and frequency.